Of all the water on planet Earth, less than 3% is fresh water, what we need for drinking, and most of that is frozen, tied up in glaciers and ice caps. So really, less than 1% of the planet's water is accessible drinking water.
Just the average guy on the street probably doesn't realize that the water that they bathe with and the water that they drink and the water that they wash their cars with comes from probably a water well.
Very deep wells. For the first time in 6 years, Las Cruces Utilities is developing 2 new wells, drilling down more than 1,000 feet to access fresh, crisp, high-quality water for the residents and businesses of this community. Dr. Jorge Garcia, Utilities Director.
In water planning, you cannot think about tomorrow or next year. That's too late. You need to think about 40 years to 100 years down the road.
Las Cruces Utilities has to determine years in advance when additional water supplies will be needed.
We look at current use, future population growth, where we are in terms of the capacity of the system, where the growth is.
Our wells are drilled into 2 deep underground basins of water.
Our water comes from 2 aquifers. The Mesilla-Bolson or Mesilla aquifer here in the valley that is tied to the Rio Grande, and the Jornada-Bolson on the east side close to the mountains.
Basically, bolson means purse. Think of it as a lake that's then filled up with sediment, and then there's still water in the base of that, inside of the pore space inside of that sediment.
For the kind of high production, high quality well needed to serve Las Cruces, that means drilling deep, protecting the water formation, and using the toughest stainless steel pipes and screening available to draw the water out of the earth. Well construction is hard, dirty work, and the crew arrives on site only after geologists, hydrologists, engineers, and designers have completed months of study, testing, planning, and design to decide exactly where to drill and how deep. Getting the funding in place for well drilling is a whole other matter.
It takes a lot of time to go from developing the resource to actually getting the water to the customer. Because you have to figure out how you're going to fund it, how you're going to pay for the infrastructure that is going to bring the water, probably for many miles through pipelines.
We work a 24/7 schedule and continuous nonstop until the well's completed.
So in the middle of the night, you guys are out here, you've got a generator, you've got lights on.
Yes, ma'am.
When the crew arrives on site, they rig up the equipment, set up surface casing, and dig mud pits for circulation fluid. This is not muddy water, and it's not coming out of the well. It's a lubricant that looks like chocolate milk and is called mud. It acts like oil in a car's engine to keep everything lubricated during the drilling. Meet Alan Ward, mud engineer.
This is where I get the sample. That's why I made this longer pole. This is the mud. This is what helps hold the hole open, lubricates a bit. It has a lot of functions.
Once the materials arrive on site, the construction crew reams the well's pilot hole into a bigger 26-inch borehole, sets a 16-inch stainless steel screening.
You can see on the sides that we basically have what's a 5/0 slot that the water can pass through inside of here. That way we can get it inside the casing and pumped up.
This special screening is engineered to allow the water to pass through in the most efficient way, but keep sands and impurities from coming in to produce a really clean water. During the drilling process, hundreds of soil samples are cut from the ground and preserved in a lithological log to provide a visual record of what the drill bit is going through.
These are physical samples that are taken on 10-foot increments as we're drilling the hole. What they're going to show you is basically a visual representation of what is downhole.
Silty sands, clays, and gravels. The crew starts hitting water for this well at 360 feet deep. Surrounding the screen is 5 inches of gravel pack, which also works as a filter to clean the water that's being sucked out of the ground.
It will minimize or eliminate the small fine sands from moving through. And so it just works as a filter. It works as a way to efficiently move water into the screen section so that we can pump it to the surface.
Then another crew arrives to develop the well. Chance Coates is a hydrogeologist.
Now we're in the point of determining how well the well itself is going to produce. So we have to test different production rates. We're cleaning out the well from any remnants of drilling mud, anything like that that could be left over.
Now, for the first time, we're actually seeing water.
We pull water, and then we turn off, we let it wash back to try to clean out the gravel pack around the well and help develop the well.
This crew takes recovery readings, tests the productivity of the well, and notes the drawdown. That's how far the water table is pulled down during pumping. They conduct water quality analysis, a constant rate test, and collect baseline field data, including pH and salinity readings.
Just the permitting process on water rights takes many years. The water rights that we got approved on the East Mesa took 20 years to approve. And with legal action and hydrologic studies and all that. So 20 years of work to just get the right to drill the wells that we're drilling.
Utilities anticipates this well will actually be put in use in late 2012 or early 2013 as part of the complex water production system bringing water to Las Cruces residents. As our population grows, as we deal with drought conditions and work to meet the water needs of our growing community, look for water conservation and water reuse and recycling to be a permanent part of our water outlook as we plan a sustainable future for all of us.